This is Honors Pre-Calculus, Chapter 6.1, Angles and Their Measures. So I'm going to start from number 24. So convert from degrees to radians. So you're going to have to multiply by pi radian over 180 degrees. Okay? You can cancel out the degrees. So you're going to get 120 pi over 180 radian. Okay? So simplify it. Divide by 60 on both numbers. That's going to be 2 over 3. Okay, next one, multiply by pi radian over 180 degrees. Cancel out the degrees. You're going to get negative 30 pi radian over 180 units radian. Okay, simplify the 30 and 180, that'll be 1 over 6. Next one, pi radian over 180 degrees. So you're going to, multiply it. So you have negative 225 pi radian over 180. Okay, you cancel out the degrees. Go ahead and then just simplify it. Divide by 45, common factor. So that's going to be 5 over 4. All right, so next one. This time is the reverse of what we did on the first 3 questions. You're going to convert the radians. So these are basically radians. Okay, you're going to convert to degrees. So multiply by 180 degrees over pi radian. Okay, so you'll be able to simplify everything before you multiply it. So simplify the radians, cancel out the pi's, simplify the 6 and 180. So that gives you 30 over there. So if you multiply it, you'll get 150 degrees. Okay, next one, you're going to multiply by 180 degrees over pi radian. Okay, so let's do the canceling. So radians are canceled, and then pi's are canceled. 4 and 180 are canceled, so it becomes 45, and then you just have negative 3 times 45 degrees. That's going to give you negative 135 degrees. Okay, so let's move on. So back to number 12. So you're going to have to draw the terminal side in the standard position. So what is the terminal side? Let's start with initial side. So this is initial side. Okay, so the initial side is basically 0 degree. Okay, you'll have to go counterclockwise for 60 degrees. Okay, so this is going to be how it looks for the 60 degrees, and this is called the terminal side. That's all you need to do. Okay, let's look at 540. So understand that you want to go a full circle counterclockwise. That's going to give you from 0 full circle, that's 360. So you know that 0 and 360 in the standard position is basically giving you the same terminal side. Okay, but in order to get to 540, you have to go another half a circle. Okay, so your terminal side is going to be right on the negative x-axis. Okay, so for this next one, number 18, I personally, just a personal preference, don't like to draw the angle using the radians. Okay, so instead, I'm going to convert this to degrees. And then you already know that if you multiply by 180 over pi, you'll be able to get the degrees, which is 240 degrees. 240 degrees, basically from the initial side, you have to go half a circle, and you have to go 60 degrees more to get to 240. So your terminal side is going to look like this. Okay, so let's look at the number 20. If you look at number 20, if you convert to degrees, is negative 120 degrees. So negative means that you have to go clockwise. Okay, you're gonna have to go clockwise. So from the initial side, you go clockwise for 90 degrees. That's one quadrant. If you go 30 degrees more, this is going to be your terminal side. Okay, so this whole thing is negative 120 degrees. All right, so 48. So you're gonna have to convert the degree to radians. So we're gonna do the same thing that we did two slides ago, a couple slides ago. Okay, so understand that you're gonna multiply by pi radian over 180 degrees. You'll be able to just cancel out the degrees and just multiply 73 to pi, and then that unit is going to be radian over 180. Understand that they want you to use 3.14 for the pi. So you're just going to multiply 3.14 to 73 and divide it by 180. You should get 1.27 radians. Okay? You're going to have to round to the two digits, two decimal places. Okay? So for the 3 radian, you're going to have to convert to degrees. So you want to use 180 degrees over pi radian. And then you're just going to cancel the radians out, multiply across. So that gives you 3 times 180 degrees over 3.14. You would simplify it. Okay, multiply divided by 3.14, you should get 171.97 degrees. Okay, so this is the length of arc of a circle. We call it the arc length. You're gonna have to use S. This is the arc length. Okay, so R is the radius, and then theta, it has to be in radian, can be in degrees. All right, so let's look at number 72. So you know that we're gonna have to solve for arc length. So arc length equals to radius multiplied by the theta in radians. So it's gonna be 12. So it'll be 12 feet. Now number 78, you're gonna use the same thing. So 3 multiplied by, but now you're not gonna use 120. You have to convert to the radian. It's gonna be 2 pi over 3. So multiply by 2 pi over 3, you're gonna get 2 pi meters. Okay, so the area of a sector. So area of a sector, we're gonna use the letter capital A. Okay, so here's a full explanation. What we're gonna do is we're gonna have to use the A equals to right here, 1/2 theta radius square. Okay, we're gonna use that formula to solve for the area of a sector. So number 80, this is what we're gonna do. A equals to 1/2 theta radius square. Okay, so we know that theta is 2 radian. It has to be in radian. And then radius is going to be 6. So this is going to be 1/2 times 2 times 6 squared, which is 36. For 86, we're going to do the same thing. So you're going to have to use 1/2 multiplied by theta. Now you have to convert this to the radian. So it's going to be 2 pi over 3. So multiply by 2 pi over 3. And then radius is 3. So 3 squared. So that's going to be 1/2. Oops. We can actually start simplifying, right? So simplify the 2 and 2, 3 and 3, because that's going to be 3 squared is 9. So simplify with 3. That left you with 3. So now you can just multiply 3 and pi. So that's going to give you 3 pi. Okay. Last question, you have to solve for S, you have to solve for A, okay? So we know that S is R times theta, And when the theta in this case is pi over 6, and the radius is 4 meters. So s equals to 4 multiplied by pi over 6. So this is going to give you 2 pi over 3. That's for the arc length. For the area of a sector, you're going to use 1/2 theta r squared. So area equals to 1/2. Theta is, pi over 6. And then radius is going to be 4 squared. So that's going to be 16. Okay, so go ahead and simplify everything. So you should get 16 pi over 12 and then simplify to 4 pi over 3. Okay, that's it for the lesson. Okay, good luck on the homework. Study hard.